Wait, you're recording? So we can go back and watch this?
How do you pronounce lemicon?
Limacons. There are 4 types of limacons, but the general form of a limason is R equals A plus or minus B sine of theta, or R equals A plus or minus B cosine of theta. If you see a number added or subtracted, another number times sine or cosine, that is going to be a limason. How do you know what type of limason is going to be? It's all about A and B. So this one's kind of cool. This one's called a limason with an inner loop. That's kind of cool, right? That's a cool graph. And how do you get a limason with an inner loop? If the ratio of A over B is less than 1. So that means if A is less than B, you will get a limason with an inner loop. What's the difference between sine and cosine? Whether the inner loop is on this side or the inner loop is on this side, that's the difference.
Wait,
You just
so
need
which
to know.
one's on the left and which one's on the right?
I don't know.
Shouldn't you know that?
I should, but it doesn't matter. So that means you don't have to know.
Yeah, but then... Easy. That's kind of hard. So are we just identifying those guys?
Yeah, basically. Cardioid. I told you that yesterday we were graphing cardioids, but really we weren't, because based on the rule here, a cardioid is a heart-shaped graph.
There's a heart shape.
Heart-shaped.
Yeah, that's what I said.
No, the technical name is cardioid. And it's not what we were doing, because to be a cardioid, A over B has to equal 1. And our A over B, those were not the same number. It was like 5 and 6. Or
So ours was a peach.
ours was the third kind, which I didn't put on here, but it is in your book. I'm going to tell you. You got to squish it up here. It's called a dimpled limason.
What's dimple?
Dimpled
It's like a dimple and kind of cheese flakes?
limason.
Oh my god, that's gross. Yeah, I like it. Oh my god.
A dimpled limason is when A over B is bigger than 1,
Are you sure?
but less than 2.
That seems a little
That
fishy.
seems weird, right? How do I say that?
Let's look it up.
It is right. I'm just trying to write it correctly.
Look it up, please.
Between 1 and 2.
Please.
You look it up. It's in your book.
You look it up, give it to me.
I know. It's right there. I'm telling
I
you.
think the real question is,
Are you the teacher? What?
So yesterday when we graphed what I call the cardioid, it was really a dimpled limason. They look very similar, but the difference is with a dimpled limason, when this comes around, it does not touch the origin. Like it goes like this.
what?
Right? Do you see the difference between that and that?
Yes.
A cardioid is going to come into the origin. A dimpled limason isn't. But it's pretty much the same thing, right?
So what about some rose curves?
Looks like the peach movie.
So there's a fourth kind called a convex limason.
Where? We have pictures for those.
They're in your book.
Something else.
On page 545.
Are we only doing cardioids and limasons though?
No.
So we're doing dimple and convex.
You need to know all of them.
Okay.
Come on, Dirk.
On the page 545, a convex limason is if A over B is greater than 2.
Okay.
And a convex limason kind of looks like a circle with one flat side. So it's like a circle, and then this side is just like flat. You ever seen a baby with a flat head? That's what it reminds me of.
Wait,
If you lay babies on their back all the time or on the same side all the time, when their head's all squishy, and it makes a flat spot.
That's not true.
You ever seen a baby in a helmet? They put helmets on babies to fix their heads to be flat. It's true.
Well, I've never seen a baby in a helmet.
Well, you probably haven't been around a lot of babies, but I'm telling you, it's why you have to rotate your child. In the second hour, they said I had my kid on a rotisserie, but I didn't. I just made sure I didn't lay him on his back all the time. Because feel your head. You can decide if you were a flathead baby. You should have like a little like place where your head goes in, right? Like it's rounded.
Yeah, I have one of those.
If you don't have one of those, that means your parents always put you in the back.
your parents are awful.
Oh, dude, my head goes out instead of in.
What? Right?
My head goes out.
You should have a bump.
Chase does like a
Wayne, do you have
Yeah.
a bump?
You should have a bump.
Yeah.
My nephew, I'll try to take a picture of your head next time I'm with him.
He has a flat
He has a super flat head because they always let him.
What's up, Wayne?
I thought that wears out once you get older. Though.
He's like 10 and he still has a flat head. That's why they put helmets on you. They put a helmet on you to reshape your head when you're little, but it's still reshapeable. Because what, like at the age of 2 or something,
So you
all the,
mold a baby's
like
head?
when you're born, without being too graphic, when you're born, your bones in your skull are not
Oh,
together because they need the head to be kind of squishable so it can make it out. You know what I'm saying?
That's
Do you
true.
know a kid named Aiden in junior
How
high?
how are babies?
His head like comes from.
Explain.
It's funny.
You know he
I'm
jumps.
old,
Aiden. Aiden. Do you know Aiden in junior high?
No.
I forget his last name.
Anyway, your skull is in like 8 pieces when you're born, so that it's squishable. And then that's why they say babies have a soft spot, because their skull is not put together. But then as it grows together, you can't shake their head anymore. So that's why if you get a flat spot on your head, you gotta put them in a helmet early to shake their head.
Baby got hit in the head, they could easily die.
Die instantly. Yes. If you see a little
That's why
baby,
you're supposed to throw them out the wall.
you can see their heartbeat right here in their head.
What?
And if they get dehydrated, they have a big sinkhole in their head because there's a hole there.
So Mike.
I'm not believing
That's
that.
what you tell
I swear to God, like I'm not
You
lying.
better show us a picture.
I didn't
You
think
better
that.
show us a picture.
My son, my little guy, had no, but he had a soft spot for a really long time, and the people at daycare were like concerned that he still had a soft spot and he was over a year old. They're like, we can see his heart beating still in the soft spot, and we don't think it should be there. So I asked my doctor, and the doctor says that it's totally fine. Like that usually it's about the age, like between 1 and 2 is when the soft spot goes together. But like that's why you have to be really careful with baby's head.
You know how they pull dents out of cars like a suction cup? You
try that with
your kid?
Plug their nose. You're blowing them out.
Oh.
It's not true. They're very gentle. This is why children should not have babies or be around them or be left alone with them.
So you let the cords around your kid's head for a little
I'm gonna make sure I let your brother know to not let you near the new baby when it's born.
Oh my gosh. Oh my.
They're very fragile.
Oh.
Right? How many bones are in the human body?
256, something like that.
206, isn't it 206?
206.
I knew it was-
When a baby's born, it's like almost 300. But they form together. Like,
No, that's what you start out as 206. You drop down to like 180 something.
that's not true.
Yeah, it's really quick.
You poop out bones.
That's not factual.
Is this on recording? You better delete this.
Brandon said,
You guys are out
I
of
feel like my
control.
kid was actually going to look up the recording. Oh,
They always tell me they're recording
That's
this too. And they can't watch it. It's all your fault.
yeah.
Just don't hit babies in the head. That's the lesson of today.
So,
Write that down. Put it on our notes or what?
Rose curves. Formula for rose curves. R equals A cosine in theta, or R equals A sine of in theta. And we'll talk in a minute how you can know if it's cosine or sine.
how do you remember all this?
What's the N stand for?
N is the number of petals. If N is odd, it's the number of petals. If N is even, then you have to take 2 times N to get the number of petals. A is the length of the petal. So you say that. A equals length of petal. Here's what we're supposed to get out of today, besides whatever the heck we're getting out of today.
Section.
If we can look at the equation and know what shape it is, we're going to be able to graph it a lot easier than just picking like 7,000 points. So looking at this picture, I know it's probably hard to read, but I think that this is 1 right here. Do you agree with that? Can you see that on your paper? Which means if I was going to write the equation for this curve, I would say that the length is 1, so A would equal 1. So N would be the number of petals if it's odd. Is it the odd number of petals?
Yes.
So that means N is 5, A is 1. So now I have to figure out whether it's sine or cosine. Do you have a guess or a thought of how I would know if it's sine or cosine?
Cosine is equal to sine of time.
So what do you think this one is?
Cosine.
I think it has to do where the petals are. Look at 0.
0 is 1, so it's cosine.
If you take the cosine of 0, you're going to get 1 times whatever A is. If you take the sine of 0, are you ever going to have a petal on the x-axis if it's sine?
Nope.
So if it's on the x-axis, that's how you know you can say this is R equals A, which is 1, times the cosine of 5 theta. Which I probably wouldn't put the 1 on that. n is 5.
No, I mean on the next one.
Oh yeah, well let's figure it out. There's definitely 4 petals on this. So if you're going backwards, that means n is 2. Yeah.
Why don't we have that?
We don't have A. Let's just call this A. We'll just say generic A. A, is this one going to be sine or cosine? Sine, because it's not on the x-axis. So it's sine, and we would say it's 2 theta, because if it's an even number, you double that to get the number of petals. So if you put 4 here, how many petals would actually be on there? 8. So
Is this seriously all that we're doing today?
Wow.
Oh, what are the sketch graphs?
it's too late to sign up to do an extra
No, he's been trying to do it for 2 minutes.
Do what? Who's the signing up for?
Too late.
Wait, what is he signing up for?
Lucas, don't tear your book apart!
Flake it
What do you
all.
want to sign up for?
Lucas!
It was just flaking. It's like
Dandruff.
It's like dandruff.
You did not do that!
Hey, you know him for doing that, but I just feel like it's on my book.
You're gonna arrested for vandalism.
Why do you gotta get off the
Is this
flaking?
what you've been throwing at me?
It's like
Yeah.
it's like if you got a
All
thread
year
coming
long,
off your
he's
shirt
been throwing
and you got a thread there, it's gonna get tugged out more. It's gonna turn the shirt more.
So he said cut the bind off completely.
I'm not sure. Well, thank you. See, that's what I was.
So how much does a book cost? I think it's
If you have a circle that just says R equals a number, it's going to be like the one from your homework, where it's just like centered in the origin and it goes around the circle. But what if you have a circle that's not centered at the origin? If you have R equals A cosine theta, it will be a circle that's on the x-axis or symmetric with the x-axis. A would be the what of the circle? The diameter of the circle. And cosine, again, should make sense that it's cosine and not sine, because cosine of 0 is 1 times A, which would give you that diameter there. So what do you think the equation for a circle on the y-axis is going to be?
Sine maybe?
A sine of theta, because this would be your A. So this is symmetric with y-axis. Then the only other graph I want you to be aware of is called a limnoscate. Limnoscate, right there, limnoscate. It kind of looks like an infinity sign. It could be like this. It could just be along the x or the y-axis. And it's r squared equals a squared sine of 2 theta, I think. I don't ever really worry about that one because I know it's the only one that has r squared in it. I guess it could be cosine also.
So basically, you chew up everything.
Chew up it. So what I want you to be able to do is tell me what shape, what kind of graph it is. And you want to be as specific as possible, which means you don't want to just say a limason. You want to tell me which type of limason if it's a limason. If it's a circle, tell me what you know about the circle. Where is it? What's the diameter of it? So as much as you can. So look at that first one. R equals 2 sine of 3 theta. Which kind of graph has a number in front of theta like that?
The symmetric.
It's not a circle. Because a circle only has theta. Right? It doesn't have 3 theta.
Then it's a
No.
it's a rose thing.
It's a rose curve.
Shit.
How many petals does this rose curve have?
Well,
6.
it's odd.
3, 6.
So it's
6 petals. It's 3. What's out?
Yeah, jerk.
N petals if N is odd.
It's odd.
Chase is odd.
I told you it's odd.
How is it odd though?
3 is odd.
Because it's 3.
Alright, I didn't know that.
If this is an odd number, it's 3 petals.
3 like what?
And how long would those petals be?
The way I do not know.
About 2.
2 inches long.
You don't know inches, but 2.
Well, it's still 2.
With length.
What? The blank 2.
2.
Next one's a circle.
Dang, he's calling you out.
Oh, he's calling you. With a length of 8.
This is a circle because it matches right there. We could even say it's a circle symmetric with the x-axis. And instead of saying a length of 8, maybe we could say a diameter.
So 8 inches diameter.
Not inches. Units. Centimeter. It could be anything, right? So we just have to say diameter.
Let's go with inches.
Limison.
It's 8 cubic meters.
I think the next one's a limison.
That's what I said.
But what type of limison?
That's limestone.
Look at their book on page 545. It tells you how to say it. It says,
Well, sometimes the book gets wrong.
it says pronounce limison.
They're equal.
They're equal. So what type of limison do have cardioid?
Which is a heart shape.
Peach.
I thought a cardioid wasn't a limison.
It is a limison. It's a special type of limison. All 4 of those on the first side are limisons. Limisons are limison with an inner loop, a cardioid, a dimpled limison. No, yeah. I didn't say it. All cardioids are limisons, but not all limisons are cardioids.
What's the? Do we do anything else for such a?
Just write cardioid.
So let's sketch the graph.
So let's graph.
Quit. Leave Brandon alone.
I think the next one is going to be...
It's a limison.
A limison? Which type of limison?
A is bigger than B.
But less than 2.
I believe it's an inner loop.
It's a dimpled limison.
Which one's what? It's A and B. It's A is first and B. A plus B.
I'm positive.
So this A over B is 4 over 3, which is bigger than 1 but less than 2, which means this is like what we graphed yesterday that I called a cardioid, but I was wrong. It's a dimpled limison.
Dimpled
A big dimple, just like that.
Like what?
I don't think you spelled limison right.
Yes, you did.
Yes.
So we need a little thing under the C.
I don't know how to do that.
It's just a line. What the?
What?
What is that?
That was my C with the line under it.
The line coming off.
No, it's like a little hyphen at about a 45-degree angle.
Whatever, it doesn't matter.
It's a lemicon now.
Actually, it doesn't matter.
It's like this.
It's a lima bean?
It's kind of like that.
That's how you pronounce it.
Where? Yeah.
So.
Why did you write MS as C?
It's like
So here's the thing. If you know it's a dimpled limison,
Dimpled limison.
I think you don't have to pick as many points as we did yesterday because I know what the shape's going to be. So I'm going to pick ones I can do in my head. You can pick as much as you want. Use your calculator. But like if I plug 0 in here, I know the cosine of 0 is 1. So 4 plus 3 is 7. So I know if I pick 0 for theta, I'm going to get 7 for r. 1, 2, 3, 4, 5, 6, 7.
1, 2, 3.
I'm going to flip over and do pi now. If I pick pi, cosine of pi is -1. So 4 minus 3 is 1. This is what makes it a dimpled limison and not a cardioid. A cardioid would touch the origin there.
So couldn't we just like part it out?
We could just hard it out, but I think we should pick a couple more points. Like pi halves. We want to be accurate, right?
yeah, we do want to be accurate.
The cosine of pi halves is 0, so 4 plus 0 is 4. And remember the great thing with cosine is I can just flip it down here.
Split that thing right over the origin.
And I think we should pick one more point, either pi thirds or pi sixths. I'm going to pick pi thirds since I know pi thirds is 1/2, but you can use your calculator. But this would give me 4 plus 3 halves, or 4 plus 1 1/2 is 5 1/2. Which is just what I hope you were doing yesterday. But the difference is, now that you know what the equations are, you should be able to be more confident and say, I know that this is what the graph's supposed to look like. There's going to be another point. It's going to be out here somewhere bigger than 5 1/2, but... Oh, I totally missed the point. But that's...
Why does this one look funny?
No, does yours not look like that?
This doesn't look very peachy.
I know, because we should have picked more points, right?
Yeah, it's a circle.
I know. That's why it's just dimple. It just has a little dimple.
Mine looks like a peach.
A cardioid looks more like a peach.
So it's next one.
What shape is the next one?
It's a rose curve.
Rose curve. How many petals is this rose
4.
curve going to have?
4.
It's even, so we double it. So we know we're going to have 4 petals.
With a length of 3.
Length of 3. So if we know that, if we can just figure out where a petal is, we should be able to kind of evenly space them, as long as you do it right. In second hour, I totally screwed up and did my trig wrong, and I was like staring at this forever, because I was like, this can't be right. And then I was like, why didn't you guys tell me I'm an idiot? And they're like, because you would yell at us if we called you an idiot.
You have a big
Oh, sure,
class in
Chris
second
tells you
hour.
I do.
I came in there and I was like, whoa.
It's
He
out.
walked in there and Ariel said, Brandon,
She did. She was mad at me. Did you remember me coming in second hour?
Yes, dear.
Yes, dear.
call me Peter.
If I put 0 in there, sign of 0 is 0.
We're gonna get 0. Let's put pi.
If I plug pi halves in there,
Yeah.
this is where I screwed up in second hour. But I should get 0 again, right? Because what's 2 times pi halves?
Yep.
Pi. Sine of pi is still 0. So that doesn't help me much,
I
right?
thought you did sine at pi halves.
But you have to do 2 times that.
So our next
So you take
one-
the sine of 2 times the angle.
It's just 1. Sine of.
No, it's not 1. It's 2
Oh, it's just
times pi halves is pi.
So sine at pi.
0. So if you get 0, that means you need to pick somewhere in the middle. Or maybe you can just think in your head, if I can just figure out what would give me pi halves, sine of pi halves is 1, that's going to be my petal length. I think it's pi fourths. If I take 2 times pi fourths, do I get pi halves? And the sine of pi halves is 1 times 3. Means that's going to be my petal. Pi fourths is right here in the middle here. 1, 2, 3. We could just wing it here, but I think that we should be more accurate than winging it in terms of
Thirds.
if we pick pi thirds, and we know what these petals look like, they're symmetric, which means if we pick pi thirds, it should be the same thing on this side. So you don't have to do a ton of work. You can type that in your calculator. I think you get like 2.6 if I remember correctly.
2 pi thirds. Sine of 2 pi thirds is root 3 over 2 times 3.
2.6. That's what I thought. So 2.6-ish, and that means on this side I know it's also going to be 2.6-ish. And then that looks like a petal, right?
That's cute.
The big issue is you have to find the other ones. And some people are really good at thinking about this, of like they have to be evenly spaced, so I know where it's going to be. It's sine, so I know it's not going to be on the x-axis because sine of 0 is 0. Are all the petals, since there's 4 and they have to be evenly spaced, does it make sense that it's probably going to be at all the fourths?
I made my thing.
If you're not sure, you can check it. And if you pick the fourths, you're going to get 3 again. So like at 3 pi fourths, you're going to get a length of 3. And they're all symmetric, which means I don't ever have to pick more points because I know it's going to be 2.6 on either side of it. So then at this pi fourths, I'm going to also have a petal length of 3 and have the 2.6
So
and a petal length of 3 and 2.6. And look how nice a graph that is. Isn't that cool?
the homework. Oh, looks like a little butterfly.
What you could probably expect to see on the test is me giving you equations and asking you to write or me giving you a graph like this and asking you to write the equation. Knowing 4 petals means there's a 2, being able to see it's a length of 3, and knowing that it's not on the x-axis, which means it's sine, and we'll kind of practice that some more. So here's your homework. 9 through 12 is matching. So I think there's the 4 types of limacons there, and they give you 4 equations and 4 graphs, and you just have to match them up. And then 63, 64, and 65, I think are multiple choice, which means this might be your best homework ever in your whole life. 53 through 56 are some crazy graphs that we're going to use the graphing calculators on. So in second hour, we didn't have a lot of time. Do you want to do that now, or you want to do that Monday? So Monday when you come in, instead of jumping around like maniacs, we want to get calculators, we want to put them in polar form, and we want to graph 53 through 56. But if you just sit here, you have, what, 13 minutes? A little less because it's fast.
13 minutes to take a nap.
You don't need to, you have no graphing today.
I'll take a nap. Well, nap.
53 through 56. I don't know, favorite. I can give you fancy graphic paper on Monday.
Brandon, I don't think you were 6'1" inches.
I think you should try.
Taylor, you should do this homework. It's really easy.
The bottom of the seat is 4 inches.